Welcome to the 9.4 through 9.8 review, where I'm going to work out each and every problem here in one video, and then we're going to see how we did. So in number 1, we're given a piecewise function, and it says first, which piece of the function will we choose to evaluate f of negative 3? What that tells us is that x equals negative 3. Which of these does that make true? Which of these subdomains does it make true? Is negative 3 less than negative 3? No, that's a false statement, so we're not going to substitute it into piece 1. So, not going to put it in piece 1. Does it go into piece 2? Negative 3 is less than or equal to negative 3 is less than 1. We substituted for x. Is this true? Is negative 3 less than 1? Absolutely. Is negative 3 less than or equal to negative 3? Yes, absolutely. So we know that we're going to substitute this into piece 2 because negative 3 is less than or equal to negative 3 is true, and negative 3 is less than 1 is true. It satisfies every part of that inequality. Now, if we want to evaluate things in the first piece, we have to take x values that are, in fact, less than negative 3. What are some examples of that? Well, negative 4, we could use there. Negative 20, that would also work there. Any number that is less than negative 3 would work for that first piece. All right, and then the last part here says, for C, what values cannot be used to evaluate the third piece. Basically, I'm saying, what does not fit here? What is not greater than or equal to 1? Well, those are things that would fit in other pieces or not fit anywhere in the domain at all. So 0 would not fit in that third piece because 0 is not greater than or equal to 1. Negative 5 is another example of something we cannot put in that third piece and have it work. Now, if we want to evaluate f of 0 in number 2, we have to look and see where is it equal to 0. Is it equal to 0 in piece 1? No. Is it equal to 0 here in piece 2? It sure is. So we're going to put it in piece 2. There is no piece 3, so we don't have to worry about that. So why does it go in that one? Because x equals 0 is part of the domain of piece 2. It does say pick an x value to evaluate using the correct piece of the piecewise function. We could use any x value that is defined. Since we're talking about 0 already, let's find f of 0. Okay, f of 0 means we're going to use piece 2. 1/2 is 0 where x was. We're going to evaluate inside the parentheses first. 0 plus 2 is 2. So 1/2 times 2 squared. 2 squared is 4. And half of 4 is 2. So f of 0 equals 2. If you chose a different x value, totally fine. It does not matter which one you choose as long as you evaluate it correctly. In number 3, we're asked to graph this piecewise function. And the first thing that I always taught was to create our fences. Where are the boundaries? I see a boundary at negative 5. So I'm going to go ahead and I'm going to put in a boundary at x equals negative 5. And I see another one at x equals negative 1. And that's where it changes from one function type to the other. Remember that at the end, we're going to need to erase those because they're not actually part of the graph, but they do help us to create the graph. Piece 1, f of x equals 5. This right here, this is a constant function, which means it is a horizontal line. Okay. So at 5, I'm going to put in at 5. At negative 5, I'm going to put a closed circle right there. To the left, it's going to be a constant function at a height of 5. All right, in the second section, the function is linear. Our starting point is, I'm going to do this one in blue. Our starting point here is negative 4, negative 2, and the slope is 2. So negative 4, negative 2, I'm going to put a point. That's not at the boundary, so I don't have to worry about open or closed circles. And a slope of 2 means over 2 and up 1. Over 2, up 1. When I get to those boundaries, I have to pay attention to open or closed circle. Both of these are not equal to. So they're both going to be open circles. And we connect because it's a function that is defined, not in a way that would make it to be discrete, but rather implies that it's continuous. All right, third piece right here is in our third section. X is greater than or equal to -1. I see a square root function, and I see a starting point of -1, -1. Okay, that is going to be a closed circle because X is greater than or equal to -1. So I'm going to put a closed circle right there. For our square root function, I'm going to make a table. This is our left and right section. This is our up and down section. 0 was the first X value that goes into our square root, then 1, then 4, then 9. We could go all the way up to 25, but I'm going to choose not to because our graph doesn't go that far. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So that tells us how far to go over and up from our starting point. Over 0, up 0, over 1, up 1, back to the starting point, over 4 and up 2. From that starting point, go over 9. Oh, that's not going to fit on our graph. So this at least gives us enough to draw the sketch that looks something like this. Almost done. We need to erase those boundaries that we drew to help us see the different pieces. Oh, did not mean to erase that. There we go. So our graph should look like that for this number 3. Number 4, we only see 2 pieces, but there's still going to be 2 fences that we need to draw. We see that it changes from one form to another at -1, from one piece to another at -1, so I'm going to draw my boundary at -1. Then I'm going to draw a second boundary here at x equals 8. That's going to be a second boundary because the piece just stops there. So piece 1 is going to be in the first section, piece 2 is going to be in that confined section. Okay, in the first piece, I'm going to do that first piece in blue. I'm going to do this one in blue. Let's highlight that in blue, just so it's clear which one I'm doing. Okay, what do I know about it? That function is linear. It has a starting point of -5, 8, and the slope is -3. So let's plot that point, -5, 8 is right here. It's not a boundary point. I don't have to worry about open or closed circle until I get to that fence. A slope of -3 is the same thing as -3 over 1. So down 3, right 1. Down 3, right 1. Down 3, right 1. When do you stop? You stop when you get to the boundary. Down 3, right 1. Okay, open or closed circle. This piece does not have an equal sign as part of the domain, so we're going to have an open circle like this. Going. Boom. As linear as you can make it. The second piece, which I'll do in green. Second piece I'll do in green. That is cube root. Our starting point, our center point is 0, 0. There's no transformations on it. There's no stretches, so we only need to worry about the parent function table itself. And it worked like this. -8, -1 rather, 0, 1, 8. -2, -1, 0, 1, 2. Now from that starting point of 0, 0, which I'm going to go ahead and plot, can we go 8 to the left? The answer is no, because if I try and go 8 to the left this way, I cross over the boundary, over the fence. Can't do it. Can I go, so I'm going to cross that out. Can I go left 1, down 1 from that starting point? I sure can. And that -1 right there has an equal sign, so it's going to be closed circle right there. 0, 0 is the starting point. 1, 1 is right 1, up 1. Next one is right 8, up 2. Right 8, up 2. And that is going to be an open circle because it's not equal to 8. So cube root looks something like that. Okay, end behavior. As x goes to -infinity means we're going to the left. What happens? Well, that graph is going up forever if we go read it going to the left. So that arrow up here is pointing up to positive infinity. As x goes to positive infinity, though, that means that we're going to the right forever. There is no arrow pointing to the right. Instead, we have this open circle, so that means it does not continue going to the right forever. The limit does not exist. It does not go to x equals infinity. Let's finish cleaning up this graph real quick. I'm going to get rid of the boundaries because they're not actually part of the function. I'm also going to erase that. So that's what our graph looks like. That's our end behavior. Let's move on. Number 5, draw your boundaries. How many different boundaries do we see? I just see the one. It changes behavior when x is 2. So I'm going to draw my boundary there. Piece 1 is on the left. Piece 2 is on the right. Piece 1, again, I'm going to do in green, or I'm going to do in blue, rather. And piece 2, I'm going to do in green. So I'm going to go ahead and label that now. Piece 1 is quadratic. I see a starting point of 1, -4, because remember, whatever happens inside the parentheses, we do the opposite. We see an a value of 2. Ooh, we're going to have to use that in a minute when we make our table. Piece 2 is a constant function. So let's deal with piece 1 first. Piece 1, the starting point is at 1, -4. Let's go ahead and plot that. Since it's not at the boundary, we're good to go. Quadratic parent function looks like this. -2, -1, 0, 1, 2. Normally that's 4, 1, 0, 1, 4. But we have an a value here of 2. So we're going to multiply all of those values by that a value of 2. Don't forget that that a value is part of the graph. Okay, now from that starting point, we're going to go left 2 and up 8 from there, which is going to put us here at -1, 4. Left 1 up 2, 0, 0. Right 1 up 2. Oh, is that open or closed circle? It's not equal to 2, so it's going to be an open circle. And I cannot go to the right 2 because that's crossing over the boundary. So this is enough to draw the left-hand side of this function. It's parabolic, so it's quadratic. We need to draw a parabola or U-shaped graph. We're good to go on that side. What's the end behavior there? As x goes to -infinity, the arrow is pointing up to positive infinity. It's totally cool to answer that question at this time since we've been working on that piece the whole time. Okay, the second one says it's a constant function. Piece 2 is a constant function for x is greater than or equal to 2. The height is -5. So that means starting at x equals 2 and going to the right forever, the height is -5. So this one, the end behavior is a little tricky. We had a problem earlier where we said something like, if I wanted to find f of 16 here, well, 16 is not on the graph, but I know that the height's going to be the same as it was at 10, as it was at 6. It's going to be the same height everywhere. That is -5. If I said, what's the f of 50? Well, we know that's still going to be the same. It's -5. What about f of 1,000? Well, that arrow is still pointing to the right. It's going to be flat, -5. It doesn't matter what x value we put in there, as long as it's bigger than 2. The height is going to be -5. So this is one of the rare examples we've seen to this point where the limit does exist, but it's not infinity or -infinity. It's just -5 for every x value bigger than 2. Number 6, boundary at x equals 1. Oh, did not clean up that boundary on the previous one. Let's go back and do that. Erase, erase, erase the fence, and then just, there we go. Okay, this one, x equals 1 has the boundary because that's where it changes from the piece 1 in blue to piece 2 in green. All right, piece 1 is cubic. There's no transformations on it, so it means 0, 0 is the starting point. I'm going to plot that. The cubic table looked like this. There's the left, right, there's the up, down. -2, -1, 0, 1, 2, -8, -1, 0, 1, 8. So from that starting point, left 2, down 8. From the starting point, left 1, down 1. From the starting point, right 1, up 1. Oh, we're on the boundary. Open or closed circle, it's an open circle there. So, boom, cubic looks like this. It's starting to curve back up a little bit as it gets to that open circle, but it looks like this. The limit as x goes to negative infinity is negative infinity. It goes down as we go to the left. All right, the green one, this one's absolute value. The starting point is 4, -3. Remember, when it's inside the function is the opposite direction of the starting point. So 4, -3. And we talked about in class how that a value really is the slope of the right-hand side. So a is 2, means on the right of that starting point, the slope is 2. And we use a slope of 2 all the way to the edge of that paper going up and right forever. And then on the left side of that starting point, it's the opposite slope. So we know the slope is -2. It's going to go up 2 and left 1, up 2 and left 1, up 2 and left 1. Is this an open or a closed circle? Oh, I see an underline there. It means it's going to be a closed circle right here. So no arrow because we don't want it to cross the boundary. I'm going to erase the fence, the boundary between the two sections, between the two pieces. As x goes to infinity, that arrow is pointing up and right. That's a limit of infinity. Cool. So at this point, we've gone through and graphed all of the ones that you're asked to graph. Now we're going to focus on writing the equation, and we're going to focus on some applications. Number 7, identify the domain and range. Domain is all the possible x values. Okay. From left to right, the furthest left to furthest right on that number line. And if there's any breaks in between, we need to include that as well. So the furthest left we start is at -6. There's no arrow, so it keeps going. It does not keep going forever. It just goes here. Every x value up until x equals 8, the graph is somewhere there. Even at x equals 0, even though there's a jump, there still is a definition there. So we're good to go. Our domain, or x values, from somewhere to somewhere. Both of those endpoints are closed circles, so I'm going to put equals 2. Goes from -6 all the way to x equals 8. If there's an arrow, use it. Then that would go to infinity. Okay. Range, on the other hand, those are our y values. The lowest y value we see here is -7. So I'm going to put y in the middle. And the highest y value, go up, 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 up. We see the graph stops here at 3. But that one's an open circle. So on the bottom, there's a closed circle at -7 for the height. But at the top, there's an open circle at 3. And that's totally fine to have an open circle. It's not actually part of the range, but it goes all the way right up to it. And that's important to state as well. Okay, f of 0 says then, if x is 0, what's the height? Which of those circles do we use? Well, we're going to use the closed circle. So f of 0 equals 2. We never use the open circle for defining the function. In this function, there are 3 pieces. The first one goes from x equals -6 up until x equals 0. Both of those are closed circles, so I'm going to put or equal to on both of them. Piece 2 goes from x equals 0, but is an open circle, so I'm going to just put less than, up until the x value of 5. And then the third one goes from an x value of 5 up until an x coordinate of 8. And because I already had 5 being defined as part of the domain of piece 2, I did not also put it as part of the domain of piece 3. Okay, piece 1 is linear. There's several different equations we could write. I'm going to use the left endpoint for all of these just because I think that consistency helps me. So this one has a slope of looks like you go up 2 and right 1, 2, 3. So a slope of 2/3. Starting value of x is -6, so I'm going to put x plus 6 in parentheses minus 2. If you did 2/3 x plus 2, totally valid. If you use the x-intercept instead, also quite valid. All right, the second piece has a slope of -2. So -2. The y-intercept would be 3. So I'm going to put 2x plus 3. Again, if you use a different point, you would get a different equation that is equivalent to that. And then piece number 3 is a constant function with a height of -7 everywhere. So that's the equation for piece 3. All right, number 8, same ideas. Domain in this one, it begins at an x value of -3. The first piece goes up to 1, the second piece picks up at 1, so there's no interruptions. And then it keeps going to the right forever. Oh, there's an arrow. So I'm just going to put this. -3 is less than or equal to x. If you also chose to put less than infinity, that's not necessarily wrong. It's just not the most efficient way of writing it. So I'm going to avoid that here. For range, range is bottom to top. The lowest y value is -4. So with -4, that is an open circle at the lowest point. So I'm not going to put or equal to. Now, what's the highest point? If you say 9, I see why you said that, but it is incorrect. We see this arrow here, which means it keeps going up and up and up and up forever. It's going to go higher than 9. It's going to go higher forever. So this would be another case where is less than infinity would be a correct thing, but because it's not the most efficient, I'm not going to write it there. All right, f of 8. X equals 8. What's the height? It's 3. And then C says, if f of x equals -2, this means that the y value is -2. Where does this graph have a y value of -2? For sake of ease of seeing it, I'm just going to draw a line at y equals -2. Where do they intersect? Right here. That's the only spot that the height is -2. That's when x equals 3. Two pieces, we can write this piecewise function. Piece 1 exists from x equals -3 to x equals 1. Both of those are closed circles, so I'm going to put or equal to on both of them. Piece 2 starts at x value of 1, but it's not equal to because it's an open circle, and continues forever to the right. So I'm not going to put less than infinity. Piece 1 is quadratic, and it looks like you go over 1, up 1. The a value is 1. The vertex is right at the origin, so it's just x squared. The second piece is linear. Again, the slope is 1. And I'm going to use the starting point, this open circle right here, of 1, -4. So I'm going to get x minus 1 in parentheses minus 4. Could put a 1 right there as well. That's the equation of that line. Number 9, domain and range, same idea. Domain here is -5 is less than or equal to x. And because that's the first piece ends at x equals 1, but the second piece starts at x equals 1. Right here we see that it just jumps. There's no break in the x value. There's no x value in there where there's no function. And there's an arrow on the right-hand side. It goes on forever. So I could put less than infinity, but I'm going to not. Range. The lowest y value here is -1. And that's a closed circle, so less than or equal to y. Again, the arrow is pointing up forever, so I'm not going to put less than infinity. There is no single highest output for this function. F of -1 is asking us to look at right when it jumps. Which one do we use? We always use the closed circle to evaluate. F of -1 is -1. The second question says, if f of x equals 1, that means that y is 1. What's the x value? I see that happen right here. I see it happen right here. There are two x values that make it true. X is at -4 and x equals 1. Both of those are solutions to that equation. Piecewise function, piece number 1, that is a square root function. How do I know? Go over 1 up 1. Well, that doesn't tell us a whole lot. It kind of looks like a root, but how do I know if it's square or cubed? The second point is over 4 and up 2. And that is part of our square root graph, right? That's part of our parent table is over 4 up 2. So I know this one's square root. There is no additional a value. The a value is 1. Starting point is at negative 5, 0, so x plus 5. I don't have to put plus 0 because it's not necessary. I messed that up. Let's start. Where does it start? It starts at negative 5. Closed circle, so less than or equal to x. On the right end is an open circle, so less than the x value of negative 1. The second piece looks like a cubic function to me, and the stretch is 1 because you go over 1 up 1, and there's no transformation to the starting point. It is still at 0, 0, so this is cubic with no additional transformations on it. That is from negative 1 is less than or equal to x because it's a closed circle, to infinity, just keeps going to the right forever from there. Number 10, write the piecewise function. 3 pieces, 3 subdomains. I'm going to put the commas in there to separate the function itself from the domain of each piece. Piece number 1, that is linear. What's the slope? It looks like down 1, right 3. That's a slope of negative 1/3. Depending on which point you choose, you're going to write a slightly different equation here. I'm going to use the endpoint, which is a y-intercept. So I'm going to put x plus 2. Nothing in the parentheses, but if you use a different point in piece 1, you're going to use parentheses. All right, this is for x is less than or equal to 0 because it's everything to the left of 0. It is a closed circle there. I'm going to use that to be this point. Piece 2 is a constant function with a height of 2, and that's from 0. I already used x equals 0 in the first piece, so I'm not going to use x equals 0 again. Up to an x value of 4. Because it's a closed circle and it's continuous, I'm going to choose that one to be equal to. The third piece is quadratic. Okay, so I know there's going to be something squared, an x in there. Where is that vertex? The vertex is right there at the point 5. So I'm going to put negative 5 inside the parentheses and a height of 3. Okay. We also see that it is reflected over the x-axis. It opens down, but if you go over 1, you only go down 1. So I'm going to put a negative 1 for our a value out there. That is for all x values greater than 4. Again, because I made x equals 4 true for the piece 2, I don't need to make it true for piece 3 as well. All right, next question says, if f of x equals 6, or rather f of negative 6, that means that x equals negative 6. When x is negative 6, what's the height? Right there, it's 4. So f of negative 6 equals 4. The next one says f of x equals 3. That means y is 3. Where do we have a height of 3? 1, 2 times. And x equals negative 3, and x equals 5. Both of those are true. List them both. Number 11, talking about Adnan going for a hike in nature. Models an hour-long travel. Here's how high above the water he was. After 20 minutes, Adnan decides to stop climbing for a bit. How high up is he at that point? Well, at 20 minutes, what's going on? 20 minutes, he's got a height of 10. 10 what? It's in feet above sea level. So I'm going to put 10 feet above sea level. About how long after he started does Adnan make it to 15 feet above sea level? So where does the height equal 15? For this one, looking for 15. Not here, not here, not here, not here. Finally, right here. That's not a lattice point, so I can't say with 100% certainty what the height is, what the time is there, but it looks like it's halfway between 40 and 50. So I'm going to say about 45 minutes after he started. he is 15 feet above sea level. When he reached the highest point of his trip, Adnan decided to eat lunch. What was his height then? The highest height we see here is 25 feet above sea level. All those are pretty straightforward. Make sure that if it's asked in words, that there's a situation you answer in words. During which time travel or interval was Adnan climbing the fastest? That's really asking where is the steepest slope. That time interval is from 40 to 50 minutes. It doesn't ask us how fast he's traveling at that point, but we will need it in a moment. When you create the piecewise function for this graph, there are 6 pieces. Each one gets its own rule and domain. I like to do the domains first. Piece 1 is from 0. I'm going to use x for the x-axis up to 10 minutes. The second one goes from 10 minutes. I'm going to make that one equal to 20 minutes. 20 is less than or equal to x, which is less than 30 for the third piece. The fourth piece is from 30 to 40 minutes. Again, I need to make sure that one of those 30s is equal to. The next one's from 40 to 50 minutes. So there's my interval for that. And then the last one is 50 is less than or equal to x, which is less than or equal to 60. So 60 has to be equal. It's part of the domain here. If we don't see a circle, we're going to assume it's closed at both ends. Okay. Piece 1, constant function of 5. Piece 3 is a constant function with a height of 10. And piece 6 is a constant function with a height of 25. Those are easy ones for me to knock out. I'm going to knock those out first. Okay. In piece 2, what happens? He goes up 5 feet in 10 minutes. So that's a slope of 1/2. Pick any point on there. I'm going to use the left endpoint for this as well. X minus 10 plus 5. So he's going 1/2 of a foot up every minute. In the third, in piece number 4, that looks like it's the same, but the height is decreasing. So it goes down 5 feet in 10 minutes. That's a slope of negative 1/2. I'm going to use again the left endpoint, x minus 30 plus 10, but you could use the right endpoint. And then for this middle, the piece number 5, in 10 minutes, he goes up 20 feet. That's 2 for the slope. Plus 5 is the height at 40. Again, you could have used the right endpoint instead of the left, but I would not use a point in between because, again, we were approximating that point that's in blue. Always use a lattice point if possible. Pay attention to scale. All right, number 12. This is our last problem on here. We're talking about cost of a parking garage depending on how many hours is shown. There's a flat fee of $5 for the first 4 hours. You charge between 4 and 8 hours. There's that charge of $5 still applies plus $2 an hour. Between 8 and 15 hours, it's 13 plus an additional $1 per hour. So the longer you're there, the less it costs you per hour. So write the piecewise function that describes this garage. Again, there's 3 pieces. Okay, the first piece I'm going to use. Let's use t for time. Or no, it says x, so we'll use x for our time. So the first piece is from 0. Do they charge you for exactly 0 minutes? No, you have to enter the garage. So I'm going to not make that equal up until x equals 4. The next rule starts at 4 hours and 1 second. So 4 is less than x all the way up to 8. And then the third rule starts at 8 minutes and 1 second. And keeps going up until 15 hours. What happens after 15? That doesn't tell us here, so we're not going to include that as part of our function. Piece 1, it's $5. The next one is $5 plus $2 per hour. but that starts at 4. So we're going to go that way. The third one is $13 plus $1 x minus, and that starts at 8. So that's what I've got going on there. Make sure you have that x minus whatever in parentheses, because otherwise it's going to double charge you for those first couple hours. Pick those points on the graph that help you write that as well. If you wrote this constant portion, if you put this constant portion at the end, if you had 2 times x minus 4 plus 5, totally fine. I'm just trying to use the wording that's in the scenario. All right, what's the domain? Domain is x values. Oop, that's the wrong pen. Domain is x values. On the left, 0. On the right, 15. And again, we said that it doesn't start charging you until you've entered in the garage more than 0 minutes, more than exactly 0. So we're going to put that in there. Is not equal to. The range, the least amount of money that they're going to charge you is $5. The most amount of money that they can charge you, according to this, if you look here, the highest height is at 20. So I'm going to use that right there. And they can charge you $20 if you park there for exactly 15 hours. How much money does it cost to park in the garage for 10 hours? You can use your graph to figure that out. At 10 hours, right there, it looks like $15. And if you're charged $11, that's a height. We can work it backwards. Right there, that's 7 hours. Those are all the questions on the review. If you have further questions, please reach out via email.